Hello, everyone. My name is Oldřich Plchot, and I work at the Brno University of Technology. And today I would like to tell you something about how to teach large language models to comprehend speech. This is the work that we do within the ELOQUENCE project, and more specifically in the work package 2 that I coordinate here at Brno. So, what is the motivation? Obviously, our motivation has to be aligned with the overall goals of the ELOQUENCE project. There are many goals, but one of them is to contribute to the technology that will enable unconstrained and natural human-machine interactions. So what can we imagine under the unconstrained and natural conversations? Obviously, many of us are used to communicate with today's computers and other systems using text interface. But sometimes it can be cumbersome. It can be precise, but it cannot easily express everything, how you feel, what is your mood, and so on. And all of this, or a lot of it, is naturally present in our speech. So what we would like to do here is to interconnect the models that are very good at modeling speech with the models that are very good in language modeling and in providing you the answers that you are used to. You can imagine talking to the systems like ChatGPT, Perplexity, and so on, just naturally, and having a good outcome. So how do we do that in general? We, of course, do not aspire to retrain one huge model that would cover all of these modalities. In our case, it would be just the audio and text, but still, this would be a lot. But instead, we would like to try to make use of existing foundation models that are already there, and the community is producing many of them every month, and they are better and better. So our goal is to, of course, save some resources and take the best of those and interconnect them together. So how do we do it more specifically? We will try to take the models, and we will attempt to align the input and output representation spaces of both of these, the text and the speech foundation models, by basically joining them into a single model via some connector module. So what is the connector module, or the core of what we are trying to achieve here? So on this slide, you can see in the left frozen large speech foundation model. It can be a whisper encoder or WAF-LM model, wave-to-vec model, or any such model that can output nice frame-wise representations of speech. On the other side, on the right, you can see a frozen LLM model. It can be well-known Llama, it can be Euro LLM, it can be Salamandra or Olmo, something that is open source and available to us. And we would like to interconnect them. So we would like to take a speech input and translate these embeddings that go out of this pre-trained model to the embeddings that the LLM model understands. So this is done via the middle part that we usually call a connector module. And to do that, there's few things one need to consider. So the granularity of the embeddings that are coming from the speech encoder is smaller. It outputs an embedding every 50 milliseconds. But the granularity of embeddings that the LLM usually accepts is a token. A token can be a word or even a few words. And we would like to kind of solve this discrepancy in the granularity of embedding. So we will first need to subsample the representations in the connector modules, so that is done via a few subsampling layers. And then we would like to enable the connector module to transform the embeddings, basically to align the both spaces together. And this is done by adding 2 more transformer layers into this connector. So effectively, eventually, this connector module is a yet another neural network, but it is much smaller than either the speech encoder or, of course, the large LLM. So once we build such an architecture, we would like to train it, of course. And this is most naturally achieved by training for the simplest task that one can think of. And the first task that is there is, of course, train it to do transcription. And that works pretty well. There are many dedicated speech transcription systems interconnecting speech encoder and an LLM. But we would like it to be more general, to basically understand speech. So we try to come up with other speech applications and alternate during the training of this to basically make the connector more robust and for the embeddings to carry more high-level information. So we will train it to the task like user's intent during the conversation. We will try to teach it how to recognize the topic of the conversation or how to identify in what state are we during a conversation and so on. So once this is done, we end up with a system that is basically enabled, has enabled speech input and works like almost a traditional LLM. But you don't lose the information that we would eventually lose if we just simply translated the speech into text via some dedicated system and then simply put it into an existing LLM as is. So this information, as I said before, this can be the emotions, the intonations, the stress, or other paralinguistic features that a good system should try to understand and also react based on them. And this is all encoded in speech, and that's why we try to interconnect these models without explicitly going to the text representation. You can read more about this work in our upcoming Interspeech paper, and the paper is going to be published soon. The Interspeech conference is there in August, and once it takes place, the paper will be publicly available on the ISCA archive, but now you can find the link already here at the archive. But this is not all what we are doing. We are, of course, trying to build a larger system, larger dialogue system. And a part of it is, of course, to provide the answers or seek an information that is there somewhere in the text domain, and the system should use it or should be able to retrieve it. So one of the fields or one of the components of a dialogue system is an information retrieval system. And here we use a similar strategy to enable the pre-trained state-of-the-art retriever system to accept speech. So we would similarly train such a connector to adapt the input space of the encoder of the retrieval system to the output state of the speech encoder. So here we would be, for example, using the whisper encoder and M3 encoder for the embeddings for the retrieval system. So we would achieve this by combining the loss, some knowledge distillation that is composed of some mean square error rate and a contrastive loss within the batch training of this process. So eventually we would be using the right part of this graph to have a speech-enabled retrieval system. And it would still return back to you the text document that you could just simply type into the keyboard on the left side of the pipeline, but now you would just have it directly obtained from your speech query. We can go even farther, and what we try to do here is to add one more branch into this retrieval that is now has a speech-enabled input, and we would add one more connector and an LLM system to basically provide some summary. So we would like to not only connect you via the speech to some grounded to some knowledge base, but also to provide a response based on the query that is grounded to the knowledge base that we are searching to. But what we are retrieving from the knowledge base is usually some larger document, and what we would like to know is a simple answer in few sentences, and that is where the response generator comes into play. And basically, it can be an LLM that will take the retrieved document and summarize it for you. So this is just an extension, again, in a similar way as we have already described in the very beginning. And all of this can be trained jointly and can be eventually very effective. So this is our most recent work that we have just published within the ELOQUENCE project. And I would encourage you to try to look at our web pages of the ELOQUENCE project. And if you're interested more, read through the deliverables of the work package 2 or deliverables of also other work packages. They're all related, and find out more about this. You can, of course, contact me or others within the project directly, and we would like to help you understand what we do if you're interested, or we can even collaborate. So thank you very much for attention, and I hope that you find this video interesting.